Hello and welcome to EduSpark Global. Have you ever wondered what percent of a compound is made up of each element? That's exactly what percent composition tells us. In this video, you will learn the simple formula, how to calculate it, and we're going to walk through example problems. Now, what is percent composition? Percent composition is the percentage by mass of each element in a compound. Percent composition is equal to mass of the element over total mass of the compound, which is the same thing as molar mass times 100. Okay? So let's look at different examples. The first example here says to find the percent composition of carbon dioxide. The first thing we will do is to calculate the molar mass of the compound. Carbon, we have 1 times the mass of carbon in the periodic table, which is 12.01. Oxygen is 2. 2 times the mass of oxygen in the periodic table, which is 16. Then we calculate 12.01 times 1 gives us 12.01. 2 times 16 will be 32. Then we add this up. The molar mass of this compound will be 44.01 grams per mole. So to find the percent composition of carbon, if the question says find the percent composition of carbon dioxide, you will go ahead and find the percent composition of all the elements in the compound. So percent carbon is going to be equal to the mass of carbon. So because carbon is only 1, the mass of carbon in that compound will be 12.01 over the total mass. This is the molar mass, remember? So over that molar mass, so 44.01 times 100. So 12.01 over 44.01 times 100 will give us 27.3%. Then the percent oxygen will be equal to 32, not 16. You have to include the total oxygen mass in the compound. So the percent oxygen is 32 over 44.01 times 100. The mass of the element over the total mass or the molar mass of the compound. So 32 divided by 44.01 times 100 gives us 72.7%. To confirm that what you calculated is correct, what you would do is to add all the percentages of every element in that compound, and that should equal 100%. That's how you know that your calculation is correct. So if we add these two up, they will give us 100%. So this is how you calculate the percent composition of CO2. Now we move on to the next question. It says, what is the percent composition of oxygen in magnesium nitrate? So this one is a bit specific. Sometimes the questions are specific like this, and you will still start by calculating the total or the molar mass. Okay, so magnesium, we have only 1 times the mass of magnesium in the periodic table, which is 24.31 grams per mole. This gives us exactly the same thing since you're multiplying by 1. Then nitrogen, this is 1 times this 2. That 2 affects both the oxygen and the nitrogen. So we have 2 nitrogens times 14.01, which gives us 28.02. Then oxygen, which is originally 3 here, would multiply the 2. So 3 times 2, that is 6. times 16. So 16 times 6 will give us 96. So if we add them up, we will have 148.33. That is the molar mass of MgNO3. So since the question is specific and they're only asking for the percent oxygen, we're going to simply say percent oxygen equals 96, which is the total mass of oxygen in that compound, over the molar mass of the compound times 100. Now, 96 divided by 148.33 times 100 will give us 64.72%. And that will be our answer. So for this type, you don't have to do all. But if they are not specific, then you are supposed to do all of it. Okay, if they just say what is the percent composition of magnesium nitrate, you are expected to do the percent of the individual elements in that compound. But if they are specific, then you just go ahead and do only that. Okay, the last question, I would like you to pause and try this one on your own before you continue watching to see the solution and the correct answer. So we are to find the percent composition of aluminum sulfate. In this case, we're doing all of it. So as usual, we're going to start by calculating the molar mass. So aluminum, we have 2. Sulfur, this is sulfur, that's 3. Oxygen is 4 times 3, that is 12. So aluminum is 26.98. Sulfur is 32.06 and oxygen is 16. And we calculate 2 times 26.98 is 53.96. 3 times 32.06 is 96.18. 12 times 16 is 192. Now, if we add them up, this gives me 342.14. So, percent aluminum, because they did not ask for a specific one, we're going to go ahead and do all. Percent aluminum will be equal to 53.96, the mass of aluminum, over the total mass times 100. So 53.96 over 342.14 times 100 gives me 15.8%. Then percent sulfur will be 96.18, the total mass of sulfur over the molar mass of the compound times 100, which is equal to 96.18 over 342.14 times 100, and that gives me 28.1%. The last one, percent oxygen, will be the total mass of oxygen, 192.00 over 342.14 times 100, and that gives 56.1%. Now, as usual, for questions like this where you're doing the percentage of all the elements, to confirm that what you did is right, add everything up, okay? So if you add it up and it gives you 100, then you did it correctly. And this one here gives me 100. So now, sometimes the question will not be a bit straightforward. They could ask you which element has the highest percent in aluminum sulfate. Okay, that's an indirect way of saying to calculate the percent composition, because you have to finish calculating to figure out which one will have the highest percent in most cases. There are some that is obvious, like H2O, without calculating, we already know oxygen will be the highest. But for some of these ones, you might have to calculate to actually see which one is the highest, okay? So in that type of question, your answer would be that oxygen has the highest percent composition in the compound. So that's it. So remember, always make sure your percentages add up to approximately 100%. If they don't, check your calculations or check your rounding and make sure that you figure out where the problem is. Today, you've learned how to calculate percent composition by finding the molar mass of the compound and determining what fraction comes from each element. We practice with carbon dioxide, with magnesium nitrate, and with aluminum sulfate. I hope you found this helpful, and if this helped you in any way, don't forget to like this video, subscribe, and leave us a comment with another compound you would like us to solve. Thank you so much for watching, and see you in our next video.